In this video, we will study how to solve questions related to quantum numbers. So let us take this question number 1. Using SPDF notations, describe the orbitals with the following quantum numbers. Means with this quantum numbers, you have to find out which orbital it is. So say for example, question number 1, A bit, N, L, M values and S values are given to me. So, suppose these are my values given. N is 3 in this case. You know N can be 1, 2, 3. So over here the N value is given 3. N is, N can be 1, that means K shell, 2 means L shell, 3 means M shell. So here we are talking about M shell. So value of M is 3. Now when N value is 3, how to find out L value? What is L? 0 to N minus 1. So that is L value. So with the corresponding to N is equal to 3, how many L values will I have? I will have 0 to N minus 1 is 3 minus 1 is 2. So 0 to 2. So I will have 0, 1 and 2. Okay. So L values can be 0, 1 and 2. Now what is the value M value? What is M? M is 2L plus 1. So if it is 0, for this value of 0, this S, 0 means S orbital, 1 means P orbital, 2 means D orbital, S, P, D, 3 means F orbital. So L shows which subshell, N shows which shell, K, L, M shell, L shows which subshells. So S, P, D. Now in M shows which orientation. S orbitals are spherical. So it has only one value, which is 0. So it is one value, because it has only one orbital. Whereas, and in this there are 2 electrons can come. So S will be either plus half or minus half. These are various possible values. Let us find out the possible values. For 1 may 2L plus 1. If L is 1, so 2 into 1 plus 1 is 3 values. That means I will have 3 values. What are those 3 values? 0, plus 1, minus 1. That means I will have an orbital with P orbitals. Px, Py and Pz. P orbitals can be shown as, P orbitals are shown like this, 3 orbitals. P orbital has 3 subshells, Px, Py and Pz, x, y and z axis, x, y and z axis. So there are 3 values, and each one of this orbital can have either plus half or minus half. 2 electrons, each orbital will have 2 electrons, clockwise and anti-clockwise. So each one of this will have plus half or minus half. Plus half or minus half. Similarly for 2, what if L is 2, then what will be M? 2 2s are 4 plus 1 5. So there will be 5 values. Plus 2, plus 1, 0, minus 1, minus 2. There will be 5 orbitals. D orbitals. D orbitals have 5. D shell, subshell has 5 orbitals. I can show it like this. 1, 2, 3, 5 various orientations. So it can be D, X, Y direction between X and Y plane, D, Y, Z between Y and Z plane, D, X and Z plane, D, X on X and Y. So on, this is between X and Y. This is between Y and Z. This is between X and Z. This is on X and Y, and this is on Z. So based on the orientation, which space, what is the orientation in space, we will have 5 values, 1, 2, 3, 4 and 5 orbitals. These are 5. So numbers related to this are 0, plus 1, plus 2, minus 1, minus 2. So there are 5 values, and each one of this is plus minus half, plus minus half. clockwise, anti-clockwise, plus half, minus half, plus half, minus half, plus half, minus half. Okay, so now over here with this quantum, so electrons can be anywhere. All of these electrons, which electron do I have to give this letter to? Which is situated in n value, which has the quantum number n is equal to 3, n is equal to 3, L is equal to, so let us see, out of this let us identify which electron we are talking about. This is 3 and then L is 2, means in d orbital, and then in m is equal to plus 2. That means in d orbital plus 2, that means plus 2 is my dxy. And then plus half means the plus half one. That means I will have from this d orbitals dxy, I will be taking the plus half, this one. So say for example, that means let's say for example this is the nucleus. This is n is equal to 1 K shell. Then you have n is equal to 2 L shell. Then you have n is equal to 3 M shell, which we are talking about over here, M shell 3. So where is the electron? Here K shell has one orbital, S orbital. This has one S and one P orbital. And this one has one S, one P and one D orbital. This can be increased. This is not here. Okay, so D, S, P and D orbital. S, P and D orbital. So third shell will have S, P and D. Now which electron? Where is this electron? Over here, N is equal to 3. That means here, somewhere here. Now then L is equal to 2. Means L is equal to 2 means S. L value for S is, L value is 0. And P value is 1 and this is D value is 2. That means somewhere in D, if L value is 2, that means it is D orbital. Now in D orbital, what is M value? Plus 2. Plus 2. Okay. So over here, how do we call this? Here it is 0, plus 1, plus 2, minus 1, minus 2. So plus 2 is somewhere here. We are talking about over here. In this case here plus 2. We can call it as dz square, you can say. Okay, these all dxy, yz, xz, they are all equal. So either you can call it as dx square, this can be dz square, anyone is equal. They are all called degenerate orbitals. So it is not wrong, but simply you have to write one of it, you have to choose. So what will be the answer? It will be 3D either xy or yz or x square minus z, whatever it may be, and it is plus half. So it will be like this. So the answer is 3dxy spin above. Okay, let's take another example. Question number B. So question number 1B. Now n is equal to 4, L is equal to 2, M is equal to minus 2 and S is equal to, here it can't be 0, it can be either, it's minus half. S can be either plus or minus half. So minus half. So let's understand from here. N, L, M and S values. So N, L, M and S values. N can be 1, 2, 3, 4, K, L, M, N. So 1, 2, 3 and we are talking about fourth. So I will directly write 4 here. Now for N is equal to 4, you can have what L values? L is 0 to N minus 1. Means 0 to N minus 1, 4 minus 1 is 3. So 0, 1, 2 and 3. These are various values of, possible values of L. You have to see L value 2. But anyways, first let's make all the values. Then You know what is m? M is 2l plus 1. So for this m, 2 into 0 plus 1 means 1 value. 0 plus 1 is 1 value. So it is 1 value which is 0. And this 1 value corresponds to 1 orbital, s orbital, because this is s, this is p, this is d, and this is f. Okay. So this is plus minus half, either plus or minus half. Now this one, what is value of L is 1. That means 2 into 1 plus 1 means 3. So it will have 3 values. What are those 3 values? 3 values. 0 plus 1 minus 1. So Px, Py, Pz you can say. And each one of this is plus minus half. For d orbital, okay, for d orbital, when I say value of L is 2, so value of m will be 2 into 2 plus 1 is 5. So it will be 5 orbitals. dxy, dyz, dxz, dx square minus y square, dxz square. It can be here, this is 0 plus 1 plus 2 minus 1 minus 2. By customary we write in this order. It can be, anyone can be 0, anyone can be plus, minus 2, anyone is dxy, anyone is dyz, anyone, all of them are equal. But we write in this order so that everybody is in the same page. And for each one of this is plus half minus half, plus half minus half, like that. So for all of them it is plus minus half. Okay, similarly for 3, what will happen? 3, if L value is 3, 2, 3 is 6 plus 1, 7 values. So there has to be 7 values. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. So 1 is 0, plus 1, plus 2, plus 3, minus 1, minus 2, minus 3. There are 7 values. For 7 values, each one of them will have plus minus half. Each orbital can have 2 electrons, one clockwise and one anti-clockwise. Now, which electron, this quantum number is for which electron? That's what we have to see. So, let's start highlighting. N is 4, means it is not 1, 2, 3, it is 4. This one. Then L is 2, that means it is d orbital. Okay. And then here it is M. M is minus 2. Minus 2 means dxy over here. And it is minus half, means it is the, in this orbital, there are 2 electrons, this and this. So we are talking about the one which is anti-clockwise. We are talking about this electron. So I have to, this quantum number is a complete address for this one electron. So I can go to N is 4, then I go to this subshell, then I go inside this orbital, and then I give a letter to this electron which is anti-clockwise movement which has. Okay, so this is how this quantum number corresponds to this. So how do I write it? N is 4, so 4, and this is D, and which one? This is dxy, and this is anti-clockwise. So this is what this will correspond to. So answer will be 4 dxy and this spin, anti-clockwise. Okay. Similarly, let's do question number 2. Question number 2. Designate the electrons with the question number 2. Designate the electrons with the following set of quantum numbers. Same way. N is equal to 2, L is equal to 1, M is equal to plus 1, and S is equal to plus half. So N, L, M, and S. N can be 1, 2. We are talking about 2 here. Then it can be for this one, L is equal to 0 and 1. And 0 to n minus 1. And then over here, 0 can be of 1 value, and this is plus minus half. And 1 can be of 2L plus 1, means 3 values, which is 0, plus 1 and minus 1, px, py and pz, and each one of them will be plus minus half. So over here when we say n is 2, this one, L is 1 means this one, 1 means this one is S and this one is P. So P orbital we are looking, P subshell. And then M is plus 1. Plus 1 means this one, means PZ, this one. Okay. So PZ and this is plus half, this one plus half. So what is this? 2PZ and plus half. So we are talking about this orbital. Similarly, let's do another question of n is equal to 4. Question number B, n is equal to 4, L is equal to 2. Question number 2B, M is 0 and S is minus half. M is 0 and S is minus half. So what will happen? Again same, N, L, M and S. So again n values can be 1, 2, 3, 4. We are talking about 4. L is, then with this 4 value, L is equal to n minus 0 to n minus 1, means 0, 1, 2 and 3. Over here we are talking about L value 2. So if for this 2 value L is equal to 2L plus 1, it will have 2 2s are 4 plus 1 means 5 orbitals. Because this is S, this is P, this is D and this is F. Okay. So this is D orbital and then this is minus half and M is 0. Okay. 0 plus 1 plus 2 minus 1 minus 2. So if it is dxy, dyz, dxz, dx square minus y square, dz square. So when we are saying plus 2, M is 0. 0 means dxz. We are talking about this. And in this case minus half. Minus half means this electron. That means what will it be? 4. L is 2. 4d xz, this one. So it is 4dxz and it is anti-clockwise. That means in an atom, suppose if I have to show this, what will it be? If this is my nucleus, this is my K shell, which is n is equal to 1, then n is equal to 2, then n is equal to 3 and n is equal to 4. 4 will have S, P, D and F. All of this. 1, 2, 3, 4, 5, 6, 7. So this is S, 4S, 4P, 4D and 4F. Where is my electron lying in this case? N is 4. N is 4th. Here somewhere. Not here, not here, not here. In somewhere here. L is 2. 2 means D orbital somewhere because this is L is 0, 1, 2. So D means 2. And then here it is 0 plus 1 plus 2 minus 1 minus 2. So if it is 0, that means dxz. Okay, it can be anything. You can write dxy also, no problem. And then it is in this case half. In this orbital of 0, there are 2 electrons. One is clockwise, one is, we are talking about the anti-clockwise one. Okay, we have to find this electron. Okay, so in the whole of this atom, which electron we are looking for with this quantum number is this one. Okay, next let's do another question of mention the values of n and L corresponding to the following. Always when we say the first one is n and second one is L, S. S, P, D, F means L and 1, 2, 3, 4 means N. So what will this be? N is here. Here what is the value of N in this case? N is equal to 1 and L is equal to 0 here. value of L will be 0. In this case, B, 2P. That means N is 2 and L values with 0, 1, 2 is S, P, D and F. So here if my P means L value is 1. Okay. Similarly 3D means N value is 3 and L value for this is 2. 4F. So N value is 4 and L value for this will be 3. So N plus L value will be 7. Generally we have studied N plus L value. That is why we need to, this question is to make you understand the value of N, how to calculate N plus L value. Okay. Next is 3S. So what will be N value? N value is 3. S value is, S is always, L value for S is 0. So total N plus L value is 3. Like that. Now question number 4. Among the following sets of quantum numbers, state which are possible. Explain why others are not possible. So let's take A. Question number 4. A. N, L, M and S. Now when I say N is 1, L has to be, for this one value of N, L value is 0 to N minus 1. N minus 1 is 0, means it is only one value. And M for 0 it is 2L plus 1. This means 2 zeros are 0 plus 1. It is only one value which is 0. And then you have plus minus half. So you have N is equal to 1. You have L is equal to 0. But you don't have L is equal to minus 1. There is no minus 1. So this value cannot exist. So this is not possible. This kind of quantum number is not possible. Let's take next question. N, L, M, S. N is equal to 1. So L will be 0. Same 0 to, and M is equal to 0 and S is equal to plus minus half. So this is correct. This is possible because for N value 1, L has to be 0 and for L value 0, M has to be 2L plus 1. 2 zeros are 0 plus 1 is 1 value. 1 value is 0. 0 is 1 value. Okay. So it is S orbital. It has 1 orbital, 1 value. Okay. So this is possible. Because you can have N is equal to 1, 0, M is 0, possible, and this is possible. So this type of quantum number is possible. Let's take N is equal to this one. N, L, M, S. What does it says? N is equal to 2. So if I have to make N is equal to 2, 1, 2. So we are talking about here and question has N is equal to 2. So L values for 2 will be 0 to N minus 1. Means 0, 2 minus 1 is 1. So there are the two possible values for this. N value is 2. For this, there are two possible values of L, 0 and 1. This is for S orbital, signifies S orbital, and this signifies P orbital. Okay. Next is M has to be 0 over here. Let's talk about, first of all, L is, N is equal to 2. So we did this. L is equal to 2. L is equal to, for N value 2, okay. For this N value 2, how many values of L are there? 0 and 1. But there is no 2 and 3. So L value 3 is not an L value. This is not possible. Because L value can be either 0 or 1. So this is not possible at all. So not possible. So this is the way how you will solve the questions based on quantum numbers. Okay. What you have to do is every time you make the N, L, M, N, S shells for every time. Say for example, if N is 1, then what will be L? N is 1, L is equal to 0 to N minus 1. M is equal to 2L plus 1. S is plus or minus half. Okay. So if N is 1, L should be 0 only. And if L is 0, M should be 2 zeros is 0 plus 1 is 1 value. One value which is 0. 0 plus 1 minus 1. These are the M values. Okay. Which signifies one orientation only. N signifies the size of an atom. N signifies the size of an atom. If N is 2, that means the size is still here. If N is 4, that means size is big. N is 3 means size is still here. Okay. This is the nucleus and atomic size, shape. This whole, if you take a circle. So size increases with the N value. Okay. So N signifies the size. L signifies the shell. This big shell. Okay. So N signifies 4 shows the big shell. N. L shows which subshell. M shows in this subshell which orientation. And S shows in this orbital which spin. That is how all the 4 quantum number gives a complete address. I'll repeat. N signifies which shell. 1, 2, 3, 4. Which shell. So I have come to this shell. N. Then L signifies which subshells. Each shell has subshells. 4 shell number 4 has 4 subshells. 4s, 4p, 4d, 4f. So L signifies the subshells and M signifies which orientation in the space on the axis. Which axis. Okay. And S signifies which spin. So in the same manner, you take for each one is plus half or minus half. Say for example for 2. If N value is 2, what are the possible values? 0 and 1. For 0, the possibilities. For 1, there is 3 values. 2 into 1 plus 1 is 3 values. So 0, plus 1 and minus 1. 3 values. Px, Py, Pz. We signify it. And then each one of them will have plus minus half. Plus minus half. Each one of them will have plus minus half. Similarly 3. So it will have 0, 1, 2. Same like that you can keep on continuing for all.